According to recent statistics, the number of paid telephones in a certain state is expected to decrease to 194,000 over the next 10 years. This represents a decrease of 17.9% from the number of paid telephones in the state at the current time. Find the number of paid telephones in the state currently. So our first step will be to assign a variable to the unknown quantity. We're trying to find the number of paid telephones in the state currently. So let's assign the variable x to that quantity. X represents the number of paid telephones in the state currently. The next thing that we want to do is to try and write an equation that represents the problem situation. As we read through the problem, we see that the current number of paid telephones minus the decrease will be equal to the number in 10 years. The current number, that's what we're looking for. We're looking for the current number of paid telephones, and we've assigned the variable x to that quantity. So we put x in place of the current number. Okay, minus the decrease. Well, what is the decrease? It says we have a decrease of 17.9% from the number of paid telephones in the state at the current time. So what this decrease is 17%, 17.9% of x. And what is that equal to? It's equal to the number in 10 years, which is expected to be 194,000. So we get x minus 17.9% of x can be found by rewriting 17.9% as a decimal and then multiplying by x. 17.9% as a decimal is 0.179, and then multiplied by x is equal to 194,000. So now that we've got our equation, we solved the equation. So first of all, let's combine our like terms. If we take 1 and subtract 0.179, we end up with 0.821. So we have 0.821 multiplied by x is equal to 194,000. Now you might notice that 0.821 as a percentage is 82.1%. If something decreases by 17.9%, then you're left with 82.1%. 100% minus 17.9% gives you 82.1%. So an alternative way to approach the problem is to say that, well, if the number of telephones decreases by 17.9%, then there will be 82.1% left. So 82.1% of x must be 194,000. All right, well, the last step in the problem is just to divide both sides by the coefficient of x, which is 0.821. So we divide both sides by 0.821. And when we do so, 194,000 divided by 0.821, we come up with 236,297.1985. Well, we can't have a fraction of a telephone, so we'll just round down to the nearest telephone, and we'll get 236,297. So find the number of paid telephones in the state currently. The current number of telephones is 236,297.